I remember in high school when I first saw things like sine theta or sine 45 degrees, I used to wonder where did this expression come from, and why was there a need to introduce these things? Because it just seemed to complicate everything. And so here I really want to go over what the motivation was of using these symbols, what the basis is. If you look at most of the trigonometry books or other sources, they would just go into a right triangle and then say, if this is angle theta, this is 90 degrees, and this is the opposite. This is the hypotenuse, and if this is the base, they would say, well, sine theta is opposite over hypotenuse. In some places, this might be called the perpendicular. This is what I'm used to. And, it might be perpendicular over the hypotenuse. And you'll have all these things, SOHCAHTOA and all those mnemonics, but all that is actually, it's not that important. What's more important is, what's the basis of these ratios? Why do we use them? And how do we actually apply them? And what's the basis? Meaning, why did we ever come up with these trigonometric identities? There's 6 of them. Why? And I think that's really what I want to address here. So let's look at, say, a triangle, a particular right triangle. I'm going to just call this 30 degrees. And I'm not going to go over where the specific ratios of these sides come in, but it's really, you will find that the ratios are 1 to root 3 to 2. So any triangle where this is 90 degrees, that's 60, that ratio is 1 to root 3 to 2. And it comes from Pythagorean theorem related to a equilateral triangle. So here, if I look at the ratio, I'm going to call this ABC. So if I look at the ratio AB to AC, which is the perpendicular to hypotenuse, is a half, right? And no matter how large this triangle is, meaning if you made another triangle, extend this like this, and let's say we call this D and E. Now, the ratio of DE to EC, which is this perpendicular to its hypotenuse, will still be half. The reason is these two are similar triangles. They both share 30 degrees. They're both 90 degrees, meaning all their internal angles are the same. So if the internal angles are the same, then ratio of corresponding sides, AB to ED, this length to ED, would be equal to AC to EC. And I can rewrite this, I can cross multiply and rewrite this as AB times EC is equal to AC times ED. And then I can rearrange this to write as AB over AC is equal to ED over EC, just same as DE over EC. So basically what we're saying is this ratio of the perpendicular to hypotenuse is always the same, no matter how large this triangle is. And what we're saying is that, I'm just going to redraw this triangle here. So if we have any right triangle, where this is 30 degrees, and no matter how large of a triangle we can make here, let's say this is DE. Probably my letters are probably not in the same place, but the idea is AB, this to AC is equal to DE to DC is equal to GF to GC, and that number is half. And essentially this is the case for a right triangle where this angle is 30 degrees. And so essentially what we do is, we can certainly use just half, or we could say half corresponds to angle 30, meaning I could do a new notation like this. The ratio of perpendicular to the hypotenuse, meaning this side to that, is half when that angle is 30. But instead of doing it that way, we decided to use this notation. Sine 30 is half. So this is not a multiplication. It's just saying the ratio of the perpendicular to hypotenuse or opposite to hypotenuse is always half if the angle is 30. And then what you find is that if you have a different triangle, for example, if this angle was, say, 46 degrees, then this ratio, AB to AC, is some constant, is some number. I don't know what that number is, but it's going to correspond to sine of 46 degrees, and we can measure it. So you can imagine that I can make a chart here, angle, and then this ratio, AB to AC, which is really what we're calling the sine of that angle. So if this is 15, this is going to be a certain number. If it's 25 degrees, certain number. And so you can imagine that this ratio only depends on the angle, and that's really the basis of why we came up with this notion of sine 30 is half. It's really just saying for that triangle with a 30-degree angle, the ratio perpendicular to hypotenuse is half. So that's really all that is. And then you have the other ratios, the cosine, tangent, and all that. But they're really just rearrangement of these expressions. The most important part is the motivation behind why we use these ratios in the first place. I mean, the rest of it is just manipulation and playing with these identities. But really, this is the core idea for trigonometry. So that completes this concept video.